Hey guys, welcome back to the channel. Today's math topic is going to be geometry basics and just looking at angles and lines. So, normally I start with key tips, but today I thought I'd just kind of explain the basics of, different things that you can approach, and then we'll just go into some problems. Okay, so the first thing here is when you have two lines that are perpendicular. So we have a line like this and a line like that, right? And they meet exactly like that. The angle between them is 90 degrees, and that is denoted by like a square. So if you see a square, that means 90 degrees, okay? Now, a straight line, we know that this, right, can just be redrawn as that. And now if, right, like I said, this is exactly perpendicular, so these two should be 90. So if we have two 90s, we know that this entire thing is going to be 90 plus 90, which is 180. Similarly, if we know that, we have a line, and this top part is 180, then this bottom part will also be 180, and so the total angle, right, around this will be 360 degrees. Okay. Now, the third rule I just want to go over is if you have two lines that are parallel, we need to denote that these are parallel, meaning that they keep going forever and never meeting, right? And then you have something bisecting them, right? Then these two angles will be equal. And then, of course, if these two angles are equal, then these two angles will also be equal, right? Because we know that this big thing here is 180, right? And if we know that this is equal to this, so 180 minus, let's call this angle 1, right? So A1 must be equal to 180 minus A1, right? That's the same thing down here. So we know that this also has to be equal. Okay, so here when we have two lines that aren't necessarily parallel intersecting each other, we know that opposite facing angles will always be equal. So this angle will always be equal to that one, and this angle will always be equal to that one. So if I were to give you like two triangles like this, you know that they share this angle would be equal for both of them. And then finally, let's just talk about triangles. So we have a right angle triangle. And so what that means is that one of the three angles is 90 degrees. One thing that is always true about triangles, regardless of if they are right or obtuse or acute or anything, is that all three angles always add up to 180 degrees. So, for example, if we know that this is 90, we know that this angle and this angle have to add up to 90, right? Because we know that this is 90. So that is a right triangle, and there's a lot of stuff that we can do with right triangles and triangles in general and all of geometry, really. But we'll get into that in later videos. And we also, the thing with geometry is that, and I guess all of math, but more so geometry, is that it's very it builds on itself, right? It's very easy to prove how one concept leads to another, how one theorem develops into another. So if you know these principal concepts, right? If you see something on the test that you're like, wait, I've never learned this before, you can kind of slowly build up to that, right? You're like thinking about it logically, you can kind of deduce it. So that's why I think that it's better not to memorize all these theorems and stuff. It's just better to memorize your core ideas and then build up from that. And then the last type of triangle that I'll talk with you guys are isosceles triangles. In which two of the sides are equal. And then, of course, we also have equilateral triangles. I'll just bring that up briefly, where all three sides are equal. And sides are directly proportional to angles. So in an isosceles triangle, where all three angles are equal, all three sides will also be equal, which means that every side will be 60 degrees, right? Because 180 divided by 3. In this case, right, again, because of our proportionality, the two sides opposite of the two equal sides will also be equal. So this angle, which is opposite from that one, will be equal to this angle, which is opposite from that one. So that's, the basics, and we're just going to get into some problems, and I'll show you guys how this stuff actually applies. Okay, four straight lines intersect at point P as shown above. What is the value of y? Okay, so if you guys remember, one of the things I told you about is when you have lines intersecting a point. Well, we know that this entire thing, right, has to add up to 360 degrees, just because, this is 90, this is 90, this is 90, and this is 90, right? So if we know that this is 60, Well, we know that the opposite thing of it also has to be 60. If we know that this is 30, we know that this also has to be 30. If we know that this is 25, we know that this also has to be 25. And if we know that this is y, then we know p also has to be y. So now we know 360 degrees, right? 360 equals, well, let's just go clockwise. So we have 30, right, plus 60, plus y, plus 25, plus 30, plus 30, plus 60, plus y, plus 25. And just to be clear, there is a faster way to do this if you just take 180, but whatever, it's fine. Both will lead to the same answer. So now that we have all our angles down, right, let's just make sure we have all the right ones. We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have everything. Now, I mean, look at this. We just have a simple one variable equation, right, where we're solving for y. And we said that y is equal to p, right? So if we find y, we know p. So let's just do this quickly. 30 plus 60 is 90, right? 25 plus 30 is 55. 60 plus 25 is 85, right? And then we have y plus y is 2y. 90 plus 85 is 175, right? So 175 plus 55 plus 2y equals 360, right? And now we have 230, right? Because 175 plus 55, right? 0, 1, then you have 3, 1, 2, right? So 230. So now you have 360 equals 230 plus 2y. Now you can subtract 230 from both sides. So you get 130 equals 2y. So y equals 65 degrees. So that's how we do number 1. Okay, so let's go on to our next one, which is 78. Points x, y, and z are on a straight line. So let's just, I think for geometry problems, it's always a good idea to draw a diagram whenever one is not given to you. So we have a line. No points x, y, and z are on that line. And we know that y is between x and z. So we can put x here, put y here, we can put z here. We don't know the distances between them, but, you know, just to help us visualize it. Now they tell us length yz, so this length right here, is 3/5 of xy, right? And length xy is 20. So we can say that length yz, right? We can call length yz, it's going to be 3/5 of xy, so it's going to be a greater length, right? So let's say, well, let's just define distance xy in terms of yz. So xy, right, is going to be 5/3 yz, right? So now we can say that this is 5/3 y, we can just call this x, 5/3 x and x, right? Now, they tell us that xy is going to be 20 centimeters. So they tell us that this is 20, right? So we can actually just directly plug that into here. So we know that yz is going to be equal to 3/5 times 20. Now, 3/5 times 20, right, that's just 60 over 5, which is just 12. Right, so it'll be 12, and that is answer choice E. However, let me look. That is not what they're asking. I'm sorry, I apologize. They're asking for xz. So we know that yz is going to be 12, right? And we know that xy is going to be 20. So if we know that yz is 12 and xy is 20, we know that xz is going to xz, right, equals xy plus yz, right? This whole distance is going to be equal to this distance plus this distance. So we know yz is 12 and we know xy is 20. So we know xz is going to equal 20 plus 12. Xz is going to equal 32. and see, like, I almost fell for that. You could fall for that too, right? By just finding the distance. You need to be careful and really read the questions closely. Okay, let's go to our next question. In the figure above, PQRS is a parallelogram. So we need to think back. What do we know about parallelograms? Well, one thing we know is that opposite sides are parallel, right? And that denotes that they're parallel. What else do we know? I mean, that's all we really need to know. We know that opposite angles are equal, but in case you don't know that, I will show you how you would get to that. But we know that it's a parallelogram. We also know, that this side is equal to that side and that this side is equal to that side, right? Using this, now they tell us the measure of PQT, so this is 50 degrees, and the measure of PTQ is 70. What is the measure of QRS? Well, the first thing I see here is that they've clearly given us a triangle, right? What do we know about triangles? Well, we know that all three angles add up to 180, right? So if we know, we can call this angle X. So we know that 180 has to equal 50 degrees, right? This side, plus 70 plus X, right? So now we know 180 equals 120 plus X, right? So now we can just subtract our 120, so we can get X equals 60. So we know that this angle is 60 degrees, right? Now, what we're asking for, they're asking us for QRS. So QRS, that is this angle right here. Well, if we know that this is 60, what can we do to find this? Well, there's a few things we can do here. Well, we know, for example, that opposite angles are equal. And I'm just going to quickly prove this for you guys. So we have a parallelogram, right? Again, we just got to draw that these two are equal, that these are equal. I can split this into two triangles, right? Now, both of them are going to share this side, and both of them are going to share this side, right? Because this, and then this, and this. So they have two sides that are the same. And of course, they have this side that's also the same. So we know that these two triangles are similar. And you don't really need to know what that means. But what this means is that all the angles are going to be proportional to each other. Or sorry, are going to be the same. So this angle will be equal to this angle will be equal to that angle, etc. So all the opposite angles are equal to each other. So we know that angle R is going to be equal to angle P, and angle Q is going to be equal to angle S. Well, we're looking for angle R, and we know that angle P is 60 degrees, right? So we know that angle R also has to be 60 degrees, and that's why the answer is E. But you could have not remembered that, but by doing what I just did here, you can kind of prove to yourself, right? Based on like those initial facts I gave you, how you can like derive this stuff on your own if you don't remember it on the test. But it is good to memorize these. And I think in the future, we might make a video where we kind of give you key facts about each type of shape and what you need to know, that stuff. But for now, just if you don't remember something, try and like build up from facts you do remember, especially triangles. Triangles are good for that. Okay, so here's the last question. The hash marks on the number line above are evenly spaced. What is the coordinate of point R? Well, this one's more so of a, it's not even a really geometry problem. But, let's just go through it. So, we know that these are evenly spaced. Well, how many hash marks do we have in between M and T? We have 1, 2, 3, 4, 5. We have 5 hash marks between M and T. And we know that the total distance is, well, we're going, from -1/4 to 5/8. So our total distance is going to be 5/8 plus 1/4, right? Well, let's just do that quickly. So 5/8 plus 2/8, right? I'm just getting a common denominator, equals 7/8. So the total distance between these two is 7/8. And we know that there are 5 hash marks. So that equals 5, and we'll denote the length of each hash mark to be X. Right? So we know what we're trying to do here is find how much one hash mark is. So what we're going to do is divide both sides by 5, right? So divide by 5, that's going to be 7/8 times 1/5, right? Which equals 7/40, right? And now, see, again, they have answer choice A as 7/40 because they're trying to trick you. But you need to, think and realize what they're asking you. They're asking for the coordinate of r, not how much each hash mark is. So what you need to do in this case is, well, you can either take the 5/8 or the -1/4 and just count over to r. So let's take the 5/8, and now we're going backwards, right? So we're taking 5/8, and we have to go backwards 2 tick marks. So minus 2x equals r. Now we know this is x, so let's just plug that in. So 5/8 minus 2 times 7/40 equals r. So we have 5/8 minus 14/40 equals r. So now we can just multiply this by 5/5 to get it to a common denominator. So you have 25/40 minus 14/40 equals r. And now we can directly subtract these. We can get 11/40 equals r. Right? So 11/40 is answer choice C. Yeah. So that last one wasn't a super, geometrical problem, but in general, geometry on this test kind of requires you to recall a few key facts and kind of build up logically. It's more of like a logic bound thing than other types of questions where you just plug in numbers. So, we'll make more videos on this. It's a complex topic. It's the hardest topic on the SHSAT, in my opinion. But just, if you study this, if you learn key facts about all shapes, you should be just fine. So, thanks for watching, guys. I hope, this helped you. If you have any questions, of course, please comment, and we'll see you guys next week.